In this lesson, we're going to look at absolute value inequalities. So we've dealt with absolute value equations before, and we know how to deal with absolute or with inequalities. Now we're going to see what happens if we combine the two. So we're going to start out with a little bit of review of stuff that you should be familiar with. First is just solving a simple equation. You just know you have to get the variable by itself. No problem, we're pros. Now, inequalities are very similar, except that they can have more than one solution. They have a whole range of solutions. So, if we look at this one, again, our steps are the same as for above. We're going to take the 1 to the other side. We got 2x less than or equal to 8, divide by the 2. So x, in this case, is less than or equal to 4. So same steps. The only thing that would have been different is if we'd had to divide by a negative number, then we'd flip this sign, remember. So in the first case, we got x equals 4. Now we have x less than or equal to 4, and we got to graph that on our number line. So less than equal to means we're going to have a solid dot, a nice big closed-in circle. And everything less than is everything to the left, so that's everything going in this direction. That would be our solution. So no problem, we can handle that. Then we have absolute value equations, which you've also been able to handle. So again, the goal is to get the absolute value by itself first. So looking at very similar steps to what we just did for the other two. So we've got absolute value of x plus 5 equals 4, and you know how to handle this. We get one positive solution and one negative solution. So we've got x plus 5 equals 4, and x plus 5 equals negative 4, and then we just finish solving those for x. We've got x equals negative 1 and x equals negative 9. So you guys can handle those, no problem. Just split it into 2 and we've got 2 solutions for x. So what in the world do we do when we have an absolute value and an inequality? We start out with the same set of steps. We want to get the absolute value by itself. So we've got absolute value of x plus 5 less than or equal to 4. So at this stage is when things get a little bit crazier. Not so bad with the positive case. Again, I'm going to end up with 2 cases. I've got x plus 5 less than or equal to 4. But when I change the sign, when I make the sign a negative, so I've got x plus 5 and I want to do something with negative 4, that's when I have to flip the sign. Just like I would have flipped the sign if I divided by a negative over here, when I make the 4 a negative, I will flip this sign. So this less than becomes a greater than. And now we've got 2 inequalities that we are going to solve. So x plus 5 less than or equal to 4. So we got x less than or equal to negative 1, and x plus 5 greater than or equal to negative 9. So less than or equal to 1 and greater than or equal to negative 9. So I've got 1, again, nice solid circle, negative 1, sorry. And negative 9, again, nice solid circle. And I want less than 1, but greater than negative 9, so that's going to be all this area in the middle. That's going to be my solution in between. And when I write an and compound inequality, I usually write it smallest number first, so my solution would be negative 9, and then biggest number last, negative 1, x in the middle. Use my less thans, and I'm golden. So not too bad, just have to remember that when you make a negative sign, you flip the inequality sign. We can do this. Let's do a few more examples. So again, we want to get the absolute value by itself, so we're dividing by 2. So to get it by itself, we're going to multiply by 2. Since this 2 is not negative, we do not need to flip the sign at this point. So x, absolute value of x minus 3 is less than 8. When I make my 2 equations, I've got x minus 3 less than 8. And flip the sign and change the plus or minus, x minus 3 greater than negative 8. At this point actually is when we need to think about whether we have a positive, whether we have an and between this inequality or an or between this inequality. And kind of a fun way to remember which is which. In this case, we're dealing with a less than, and we're going to think of this as a less than. So this that we're starting with, the original sign of a less than, is going to be an and inequality. less than, we kind of made a play on words, is going to be an and inequality. So when we start out with a less than in our original equation, we're going to have an and in between our two inequalities. And then from there, we just solve like normal. So we're going to add 3. So we've got x is less than 11. And add 3, x is greater than negative 5. And those, again, have an and between them, less than and we can graph that on here. So we're going to go all the way from x is greater than negative 5, all the way from the smallest number here, all the way up to 11, and we are everything in between those two, greater than negative 5 and less than 11. That's going to be my solution. Nice solid circles at both ends, in addition to my little dish dash. Taking a look at the second example, what I've got here again, I need to get my absolute value by itself, so I'm going to subtract the 4 from both sides. This is going to be negative 21. When I divide out the negative 3, remember that I need to flip my less than to become a greater than sign. When I divide by negative, flip the sign. And now I've got a greater than, so when I had less than, I had less than. When I have greater than, it's going to be greater than, and you're looking at an or. So again, kind of a funky way to think of it. Greater than is going to end me with an or between my two absolute value inequalities. So I'm going to have my x plus 1 greater than or equal to 7, or x plus 1, remember when we add a negative, we're going to make this a negative 7. We flip this sign, so it's going to be less than negative 7. So subtract the 1, so I get x is greater than or equal to 6, or x is less than or equal to negative 8. And let's see how those graph on my number lines. I have my negative 8 down here, my 6 up here. Again, we're dealing with equals, so I've got a nice solid circle. You know what I just realized? On the last one, we had no equals. We shouldn't have had solid circles at the end there. Let me just fix that. My mistake. I am so sorry. This should have been at the negative 5 an open circle, and at the 11 also an open circle. I apologize. So on this one, I've got x is less than negative 8. So less than negative 8 is going to be going to the left from negative 8. Or greater than 6, going to the right from 6. And that would be what our inequality graph looks like. Now, when we talk about writing compound inequalities, this is just a little bit of a review, writing them from a graph. When we've got two pieces, we're going to have an or between them. So this looks like I think that's supposed to be a closed circle, a filled in circle at negative, we're counting by 2's, look at that. Each thing is 2, 4, 6, 8, so this is going to be negative 10. And x is going to be, in this case, less than or equal to negative 10, because it's a filled in circle. And on this other side, we're looking at 12, 14, x is to the right greater than 14, and I put my nice or between them. So when I've got two pieces, I'm looking at an or, and I got to be careful which ways my inequality will go. When I've got only one piece, I'm looking at an and. So x is looking at negative 7 greater than negative 7, because we're going to the right of negative 7, and x is less than or equal to, filled in circle, 6. And usually when we have an and inequality, again, we want to write them as just one. So I'm going to write negative 7, write my x in the middle, write the 6 on the other side, and use my less thans. And this one needs an less than equal to. And that would be my answer looking at this number line. All right. A few more examples. This time I want you to try it on your own and then come back and I will show you the solution. So pause your video now. Alright, so here we've got our solutions. To move this fraction, get rid of this fraction, we're going to multiply by the reciprocal of both sides. Watch your fraction multiplication. And then at that point, again, we're looking at greater than. So we're looking at an or statement. Solve them both. Or statement, greater than 8 to the right of 8, less than 2 to the left of 2. Or this one, we want to get the absolute value by itself, to minus the 4, divide by the 2, and again create two equations, less than, we're looking at an and between the two, and then again m is greater than negative 4.62. Be careful when you divide by the negative, by the way, make sure you flip the sign. So greater than to the right and less than 8.34 to the left, so m is between negative 4.62 and 8.34. Last few things, special cases. There are some special cases that we want to take a look at really quickly now. And that is something like this. Absolute value of 2x plus 1 is greater than negative 9. Now we can't have it equal, an absolute value equal a negative number, but we can have it be greater than a negative number. In fact, all numbers that you plug in will give you a number greater than a negative number because it's either going to be 0 or positive, which is always greater. So this would be something like infinite solutions, or you could also write all real numbers. Now, what happens if you didn't recognize this right off the bat, that this was an absolute value greater than a negative number? If you tried to solve it, this is what we would get. So we have 2x plus 1 greater than negative 9, or 2x plus 1 less than positive 9, and we solve this. We got x is greater than negative 5, or x is less than 4. So x is greater than negative 5 or x is less than 4. So we go to our number line and we go, okay, negative 5 is down here. 4 would be somewhere up here. Okay, greater than negative 5. Well, greater than negative 5 is going to be everything to the right of negative 5. So if we start there, to the right of negative 5, so we go shading in everything all in this direction. And then less than 4, well, that's at 4, less than 4, everything to the left of 4, that's the whole number line. We've crossed our open circles, so we've considered them as well, everything. That's why we get all real numbers or infinite solutions. Anything you plug in counts. If you don't believe it, try it. Plug in a negative 5, see what happens. Plug in a 4, see what happens. Plug in a 0, see what happens. Plug in a negative 6, see what happens. Any number will work. This is one of our special cases where we have all real numbers. One more special case is this one, and to solve this one we actually need to get the absolute value by itself first. So if we divide by the negative 3, so we've got absolute value of 2x plus 1, absolute value, and remember when we divide by a negative we flip the sign, so less than negative 3. When we get an absolute value less than a negative, we know the answer is no solution. This can never happen. A positive number is always greater than a negative number, so again, less than negative can't happen. And again, if you don't recognize this right off the bat and you try to solve it, create your two equations, we would have like 2x plus 1 less than negative 3, 2x less than negative 4, x less than negative 2. And remember that this is less than, so this is and 2x plus 1 greater than 3. So I've got 2x greater than 2, x greater than 1. So I need a number that's less than negative 2 and greater than 1. So again, if I try to put that onto my number line, this is an and. I need it to be something that fits both conditions, not just one of them. So a number that's both less than negative 2, well, less than negative 2 is going to be off to the left, less than negative 2, and greater than 1 would be off to the right, but this would be like an OR solution. So none of them, we have to be where it was between the two overlapping, so there will be no solution. Nothing will work. If you try plugging in any number here, you're always going to get a false inequality. So those are your two special cases of inequalities. Hopefully those make sense, and I'll see you in Zoom.